Hello, I'm a mathematics teacher in Seise Muramba, District, Western Province. We are on the unit number 9, which is called the derivative. We needed to discuss for application of derivative, especially rate of change for corn. Here we have one example which said a tank is the form of an inverted cone having 88 meters and the radius 2 meters. Water is flowing into the tank at rate of 1/80 meter cube per minute. The question is, how fast is the water level rising when the water is 2.5 meters deep? Now, to answer the exercise or the question like that one, we need to focus for many things like to draw an inverted cone, to understand the variation of meter cube per minute, and to understand the focus for the question, how fast is the water? Fast means speed. Fast means speed, means rate of displacement or the distance with respect to time. Now, the data we have height, which can be presented by capital letter hash, maximum height, and the radius of cone. Presented by capital letter R. And now we need to draw an inverted cone. We suppose this one is an inverted cone, which is have maximum height, and this is center of base of cone, which have maximum radius. In this case, the water maximum radius. The water throwing into the tank means the water come here, and you see here we have one point of the cone on the beginning of this tank, and if the water increase, the radius also increase. Means what? Means here we have a small height and we have a small radius where the water is, because the water into throwing the cone. Now, because what if the water throwing into the tank, the height increase, sorry, and also radius from here up to here increase. Means there is a ratio between radius and the height. Maximum height and maximum radius means hash over R, which will be equal to maximum height, which is equal to height, and the maximum radius, which is equal to 2 meters. This gives a ratio which can be h will be equal to 4R, or R is equal to h over 4. Now we have a rate of volume with respect to time. Means we need the volume of cone, which can be represented by V, which will be pi R square over 3. Now, because we have the rate of change or rate of volume with respect to time, can be denoted by dV over dt, means we need the derivative of volume with respect to time. In this case, we have dv over dt, which will be equal pi r square h over 3 derivative. But we have two parameters, r square, r and height. But the question focus to deep. Deep means height. Means first of all, in order to make this derivative, we need to substitute this radius in this formula. The reason why I'm going to call this one 1 and this one 2. Then substitute 2 in 1. So we get dv over dt with respect to time, which will be equal pi hash over 4 square times the hash or over 3. Now we get pi, then all derivative. Then we get pi hash square times the hash over 48. Now, because this is a maximum hash or maximum height, and this is a moral height, and we're going to focus for where the water is into deep of 2.5 meters. The reason why, in this case, hash, capital letter hash will be equal to small letter hash, which means dv with respect to dt will be equal to pi hash cube over 48 or derivative. Because we make the derivative of time, means here we have a 3 pi hash square times hash derivative over 48. This hash derivative is d hash over dt, which is unknown. Means d hash over dt is rate or speed or rate of change, rate of height with respect to time. Then we get dv over dt, which is equal, we can simplify, pi h square over 16 equal to d hash over dt. Now continue with the data. dv over dt is 1 over 8, and we have the water where is rising, which is equal to 2.5. It means we have here pi times 2.5 square over 16 times the hash with respect to time. With this case, we have to make cross product. We have a 16 over 8, which is equal to 2.5 square times the pi, the hash over dt. Then we get 2 over 2.5 all square pi, which is equal d hash over dt, and we get finally 2 over 6.25 pi, which is meter per minute, which is equal d hash over dt. This is the final answers. So thank you very much for following this course. Next, I'm going to show you the rate of change for isosceles trapezium. But before that, we have to go to YouTube and write rate of change for isosceles trapezium. You are going also to discuss that one and see the different teachers who discuss for rate of change for Kwon, for isosceles trapezium, and me also. I will going to prepare another reason for this application of this case of rate of change for isosceles trapezium. Thank you very much. Thank you to following me. Next time we will be together. Thank you.